refraction by glass slab. Okay, so make a glass slab. Okay, okay, this, make a glass slab and then a light ray is incident on it. Okay, this light ray is called incident ray. Okay, then if incident ray does not get refracted at the first interface, so this is air, this is, let's say, glass, and this is air. Okay. Okay, now you have to draw the normal at this point. What is point P? Point of incidence. Write this. Okay, everyone. Ray AB is the incident ray. Ray AB is the incident ray. बाद में ये सब बाद में. Point P is the point of incidence. Okay. How do you make the normal? Normal should be perpendicular to the surface, to the interface. Okay. Should be perpendicular to the interface or surface. So the normal at point P will be like this, and it is N1. Okay. N1. You can write N1P is the normal. Okay. Ray. Or what about angle APN1? Yeah, angle of incidence. I. You should, all these should be there in a notebook. Okay. APN1, this angle. This angle is angle of incidence. Hello. थोड़ी देर में टेक्स्ट कर देता हूँ. ठीक है. Now, if you want to write, so this ray will bend towards the normal, away from the normal? Towards. Why? Because glass is dense. All right. Glass is denser. Okay. So ray will bend towards the normal because glass is denser. Now, Mahita, you tell me whether the ray will go like this, or like this, like 1, 2, or 3. 3. Okay. Why? Why not 2? Okay. So these two are wrong. 1 and 2 are wrong. And only 3 is correct. Okay. 3 is the angle of refraction. Okay. Now एक काम करते हैं, ये ray ऐसे आगे, sorry, this ray was going forward, no? So I'll इसको आगे लेके जाऊंगा यहाँ पे point Q पे. ठीक है. Angle QPT is called angle of refraction. Yeah, angle of refraction. And okay, now if you want to write Snell's law, so what is Snell's law here? If the refractive index of air is 1 and the glass is suppose n.
No, is that sine theta? Sine, so it will be sine I by sine r is constant.
Sin I
By sine
into उसके अंदर किस रिफ्रैक्टिव इंडेक्स में है वो?
n.
Sin I किस रिफ्रैक्टिव इंडेक्स में है? n में है.
Yeah.
I एंगल ऑफ इंसिडेंस
Yeah.
किस मीडियम में है?
Air.
एयर में कितना एंगल? एंगल आई है और एयर का रिफ्रैक्टिव इंडेक्स कितना है? रिफ्रैक्टिव इंडेक्स एयर का व्हाट 3?
1.
हाँ 1. सो बेसिकली स्नेल्स लॉ ये बोलता है, स्नेल्स लॉ ऐसे लिख लो, स्नेल्स लॉ कि द रिफ्रैक्टिव इंडेक्स ऑफ मीडियम ये लिखो, रिफ्रैक्टिव इंडेक्स ऑफ मीडियम इनटू साइन ऑफ एंगल in the medium is equal to constant, is always same. Okay,
Can you remove this?
so refractive index of the medium into sine of angle in the medium is equal to constant. ठीक है? Fine.
Yeah.
Everything is visible now. ठीक है. Therefore ये कांस्टेंट पहले एक बार एयर के लिए लिखेंगे तो क्या लिखेंगे? रिफ्रैक्टिव इंडेक्स ऑफ एयर कितना है? 1 इंटू साइन ऑफ कितना एंगल है एयर में? आई. और अगर ग्लास के लिए लिखेंगे तो क्या लिखेंगे?
Sin r.
पूरा बोलो ना क्या?
Refractive index of glass,
which is n into sin r. They both are equal. Okay. Fine. ठीक है. From here you can conclude that also, here also you can conclude that r is less than I because the left side is sin I, right side is sin r, and this number is greater than 1. ठीक है? Anyhow, now see. If you make the normal at Q and you call it, so this is N2, okay? And suppose this is V. What is angle VQT? VQP, sorry. Okay. First tell me, देखो इधर ध्यान सुनना, ये रेक्टेंगुलर ग्लास स्लैब है, तो इसका ये वाला साइड पैरेलल है इस साइड को, both the lines are parallel, right? If these two parallel lines are there and n1 is the normal to one parallel line and n2 is the normal to another parallel line, which two are parallel?
n1 and n2.
So because it is rectangular, so this is important, okay, right? Because it is rectangular in shape, the slab is rectangular in shape. इसका मतलब क्या होता है? उसके the edges are parallel, okay? Edges are parallel. Because of these edges are parallel, what we have is
parallel lines.
Yeah, edges are parallel lines, and therefore the normals are parallel to each other.
Yeah.
The normal at the left interface, which is n1, and the normal at the second interface are parallel. So n1 parallel to n2. Okay. I'll give you another example. For example, it is not a rectangle. Suppose it is, the shape is, instead of rectangle, it was like this. Fine. Fine. And a lot of light comes at this phase, right? Or यहाँ पे when you make normal, the normal looks like this, right?
Yeah.
And then if you want to, so wherever it interface, it goes, it doesn't matter whether you make it here or it make it here or make it here, wherever. The normals N2 will look like this, right?
Yeah.
In this case, because these edges are not parallel, because the rectangular edges are not parallel, right? These are not parallel. The N1 is also not parallel to N2. Understood? So only in case of rectangle, N1 is parallel to N2. Now, because N1 is parallel to N2, PQ will be called a
Diagonal.
क्या बोला?
Diagonal.
No. Between two parallel lines, if a line intersects them both, what is it called? Very good. Therefore, PQ is a transversal. If PQ is a transversal, then what are equal?
Angle P, TPQ and VQ.
Yeah, these two are equal, right? And therefore, this angle should also be R.
Yeah.
Understood? These angles are alternate interior angles. Okay, are equal. So therefore, that angle is also R. Clear?
Yeah.
Therefore, because it is transversal, we have alternate interior angles. Alternate interior angles are R. Okay, समझ में आ गया ये? ठीक है, इसको लिख लिया है ना पक्का? लिखो इन केस ऑफ प्रिज्म, इनकी सपोज एक प्रिज्म लोग ऐसे, ठीक है, प्रिज्म ट्रायंगुलर इन शेप, उसमें the normals are not parallel. Therefore, inside refraction angles are also not equal to each other. Okay, the refraction angles inside this angle is not equal to this angle. Yeah. Okay. Understood, everyone?
Can you go up a little?
Fine. Now write एक क्वेश्चन लिखो, ठीक है? एक ग्लास स्लैब है and there is another glass slab, ठीक? So question ये है कि केस नंबर 1 में at light comes from inside और दोनों everything is same है, okay? Both glass slab are same. Light is coming at an angle of let's say 45 degree, ठीक है? And when it refracts at a refractive angle of 30 degree. Outside is air. You tell me what is the n of this? What is the n of this? Okay. N मतलब refractive index. Mahita, what we are going to do? What is Snell's law? Sine of the angle. So when you write it for air, what will you write? Right? What is the refractive index of air? 1. 1 into
1 into sine
45, right? Sorry, 1 into sine 45 is equal to, when you write it for glass, what do you write? What is the refractive? N into
Sine.
sine 30. Yes. Write both values and then find n. They both are equal. 1 into sine 45 is equal to n into sine 30. So both are equal and therefore n is equal to. Prajwal, what is n equal to?
Root 2.
Root 3.
2, 2.
Root 2. 1 second. Hello. Green berry. हाँ बोलिए. अच्छा. अच्छा ठीक है. मैं भी देखता हूँ उसको थोड़ी देर में. मैं क्लास में हूँ. मेरे को देख मेल पे भेजी है ना आपने. ठीक है ठीक है. ठीक है. तो n is 1 by root 2 is 1 by 2. Yeah. Root 2 no.
Yeah.
Right. Now सेम क्वेश्चन है. यहाँ पे क्वेश्चन है कि अगर ये सेम ग्लास है n is equal to root 2 है. ठीक है. And the question is reverse this time. The light is going from this such that its angle is 30 degree. Light is going from this such that the angle is 30 degree. At what angle does it come out? What is theta equal to? So it goes in at 30 degree.
Sir, it will be same 45 degree only.
It will be 45 degree, but you can find it out also. Okay.
Yeah.
Srijan, did you get how in the first the answer is root 2?
Yeah.
Mahita, you got? Okay. Okay. Now understood. 45 degree theta is 45. Therefore, right, when light enters from rarer to denser medium, right, when light enters from rarer to denser medium, okay, the path taken by it when light enters from rarer to denser medium, the path taken by it is simply retraced in the reverse direction. Is simply retraced in the reverse direction when it goes from denser to rarer medium. Okay. What is the meaning of the statement? So
That is But if you send light across a medium, from medium 1 to medium 2, it will be the same as sending the light from medium 2 to medium 1. The
Yes.
same path.
Yeah. Okay. So if it goes from I to R, medium 1 I, medium 2 R, then if it goes from medium 2 R, it will emerge out medium 1 as I. Okay. Therefore, okay, ये जो डायग्राम है ना अपना, ये लाइट रे जा रही है ए बी, फिर पी क्यू, ए बी पे एंगल कितना है, इंसिडेंट एंगल कितना आई, फर्स्ट इंटरफेस पे इंसिडेंट एंगल कितना है आई, और रिफ्रैक्शन एंगल कितना है आर। फिर सेकंड में ग्लास से एयर जा रही है, ठीक है, तो अंदर आ रहा है तो बाहर कितना होगा आई। अंडरस्टूड? अंदर आ रहे तो बाहर, समझ में आ रहा है कि नहीं? हाँ ठीक है, such that this is I, okay, it is same as this, fine. Now write the ray AB and QX. The ray AB and QX are parallel to each other. Okay, the ray AB and QX are parallel to each other. Thick. Fine. Also, this much is enough. Also write AB and QX are not coincident lines. They are parallel, but they are not coincident. तुमने parallel लिख लिया ना? लिख लो, but they are not coincident. They are not the same lines. Okay. So I'm going to extend QX. Okay. If you're going to extend QX, it is going to look like this. Fine. Fine. They are shifted, and the perpendicular distance between them. The perpendicular distance between them, between these two parallel lines, it's called lateral displacement. It's called lateral displacement. ठीक है? Also write the statement. We can only find distance between two parallel lines. We can only find distance between two parallel lines. Between two not parallel lines, distance is not defined. Hello. Hi, I'm Ashish. You might have called me for classes. Yeah, I'll call you in sometime. You had called me in the morning, so I'll call you in sometime. जी हाँ, तो so suppose this example simple है. If suppose there are two lines which are, see, either two lines will be parallel or they will be intersecting, because lines are infinite, right? Are these two lines parallels or are they intersect? Huh? Very good. देखो एक question लिखो. Are these lines parallel or they are intersecting? What do you think, Srijani?
Intersecting.
Yes, they are intersecting. बोला लाइन इनफाइनाइट होती है ना. इनफाइनाइट मतलब क्या होता है? सामने जितना देखा सिर्फ उतना नहीं, दोनों साइड है. ठीक है? So are these line parallels? No, they are not parallel. Are these intersecting? Yes, they are intersecting, even if you make this much. Okay? So there is nothing called distance between them, because the distance between them changes, right? Right? It will be zero sometime also, right? So there is nothing called distance between them. But if two lines are parallel, then there is always the distance is fixed. Okay, this the D. So this is the distance between them. Okay, they are parallel. Yes, they are parallel. Parallel, yes. Parallel, no. Okay. Fine. ठीक है. So you will only talk of lateral displacement when two lines are parallel. ठीक है. Okay. So therefore, right, there is, अब देखो लाइन में क्या है, प्रिज्म में हमने देखा कि N1 is parallel to N2 पढ़ा था और PQ ट्रांसवर्सल था. उसी वजह से लैटरल वो रिवर्सल हुआ ना. ये जो R बराबर हुआ है, R बराबर हुआ है किस लिए हुआ है, क्योंकि ट्रांसवर्सल था, राइट. R बराबर होने की वजह से ये I आया. इसी वजह से AB is parallel to QX आया ना. इसका मतलब इसी रीजन से ये भी आया है, AB is parallel to QX, right? आया ना, right? That means we can only talk of lateral displacement in a rectangular glass slab. Prism में lateral displacement नहीं होगा. ठीक है ना.
Then what is deviation?
Deviation है angle deviation. Angle deviation, हाँ, good. इसमें इस केस में if you write something as direction of this AB, is the direction of AB and QX same?
Yes.
Yes. Direction same है ना. तो direction change हो रही है क्या?
No.
नहीं. तो angle change है. अगर मैं बोलूं what is the angle between AB and QX, what will you say? जैसे यहाँ पे बोलूं what is the angle between line L1 and line L2?
It's 180 degree.
Okay, why did you say 180 degree?
Because like there's a line between them and the line's angle is 180 degree.
Okay.
That's perpendicular to one.
एक्चुअली एंगल ऐसा होता है कि एंगल जो है ना वो चीजों को उठा के रखने से चेंज नहीं होता. कितना एंगल है अभी?
0.
0 बोल सकते हो, 180 भी बोल सकते हो, 360 भी बोल सकते हो. ठीक है, तुम्हारा मन. तो 0 बोल देते हैं, ठीक है, फॉर सिंप्लिसिटी. तो इनके बीच में एंगल कितना है? 0. तो टू पैरेलल लाइंस के बीच में एंगल कितना होता है? राइट. द एंगल बिटवीन टू पैरेलल लाइन इज 0. So therefore, angle between AB and QX is 0.
0.
Therefore, how much has AB turned? 0. When it came out, when AB went inside, it became QX. And how much is that turned? 0 degree. So what is the deviation? Angular deviation, 0 degree. Okay. So that's why angular deviation is 0 degree. Okay. Let us talk in terms of prism. Okay. Prism में ऐसे ऐसे दिखाया. ये मोस्टली प्रिज्मर क्या होता है कि आइसोसेलस होते हैं. तुम्हारे सिलेबस में शायद इक्विलैटरल है, डजंट मैटर. अपने को बस ये चाहिए कि मिनिमम आइसोसेलस तो चाहिए. ठीक, आइसोसेलस ही होता है, आइसोसेलस नहीं होता प्रिज्म. ठीक है. एंड दिस इज कॉल्ड A is angle of prism. Okay, angle of prism. So because it is isosceles, you can vary A, and therefore your x and x will be x. These two angles will be adjusted, equal होंगे, and A plus 2x is 180 degree. ठीक है. तो A is angle of prism. So when they have given you angle of prism, कि suppose some prism का angle है, suppose let's say 40 degree. ठीक है. If they have given like this, then it is automatically assumed that the prism was what kind of triangle? No.
Sorry.
Isosceles.
Therefore, the other two angles are
70.
70, right? ठीक है ना? समझ में आ गया ना? If A is 40 degree as angle of prism, then the other two angles, it is a 70, sorry, it's a 40, 70, 70 prism. Okay, understood? ठीक है ना? Mahita, if A is 50 degree, what are the two angles?
It's
a 50, 65, 65 degree prism. Okay. So this is specified 50. Other two are equal and you find them. ठीक है. Now अब देखो लाइट मारो इस पे. लाइट मारी यहाँ पे, ठीक। पहले वाले पे नॉर्मल बनाते हैं, नॉर्मल उसका नाम है N1, N1 ये पॉइंट है P, ठीक। अभी लाइट जब मारोगे ये ऐसे निकलेगी, ऐसे, ठीक। जरूरी नहीं कि पैरेलल हो, जरूरी नहीं कि दिस रे which is this intermediate ray is parallel to the base, okay. Yeah, it can be not, so this line which I just made, it need not be parallel to the base of the prism, okay. It need not be parallel to the base of the prism. Only in one particular angle of incidence, it will be parallel to the base of the prism, okay. Only in one particular angle, ठीक, okay. Now the normal at this interface, make the normal at this interface ऐसे लिखेगा N2 and thing which is like, sorry, emergent ray. This is intermediate ray. Okay, right, this is I, this is R1, this is R2, and this is E.
Sir, is I equal to E?
No, not always. Okay,
If it was parallel,
if the intermediate ray was parallel to base, then I would be equal to E and R1 will be equal to R2. Okay, then only.
in the glass lab also the I2 is
I2 is equal to
which is
I1.
the emergent angle.
हाँ,
That was emergent angle.
you can call it, yeah, emergent angle in the glass slab, the सबसे चौथा वाला angle.
Yeah.
E बोल सकते हो. ठीक है. Now write important thing. एक चीज लिखो यहाँ पे क्वेश्चन. Mu is inversely proportional to lambda. Mu is inversely proportional to lambda. Mu मतलब refractive index और n. अब लिखो विबग्योर. फिर लिखो lambda red is more than lambda violet. ठीक है. Lambda of red should be more than lambda. इसमें lambda बढ़ता रहता है, ठीक है. Lambda increases. Mahita, whose lambda is more, yellow or green? Yellow. Whose lambda is more, blue or orange? Okay. Okay. So lambda is inversely proportional to mu. That means mu of red and mu of violet will be higher. Mahita. Yeah, mu of violet. ये लिखो, ठीक है. Mu of violet will be higher. Mu of blue and mu of violet किसका ज्यादा है? ध्यान से देखो. Violet. Rajal, fill a color here.
Sir?
Fill a
What
color
should-
here.
Okay, 1 second. Orange.
येलो ज्यादा है. Yes. करेक्ट, ठीक है ना, फाइन. व्हाट इज द मीनिंग ऑफ दिस? मीनिंग ऑफ दिस ये है, ये ग्लास स्लैब है, इसके इधर एयर है और इधर है ग्लास, ठीक. अभी एक आ रही है ब्लू, एक आ रही है रेड, ठीक है, एक आ रही है ब्लू और एक आ रही है रेड, ठीक है. सो एक लाइट रे इज ब्लू, सेम एंगल पे आ रही है, ठीक, और एक आ रही है उसी के साथ में रेड पैरेलल, ठीक. ऐसे मान लो इसी के ऊपर ओवरलैप है और इट डजंट मैटर, आई मीन आई एम मेकिंग इट डिफरेंट बट दे आर सेम. व्हिच विल हैव मोर रिफ्रैक्टिव इंडेक्स? Blue will have more refractive index. Blue will experience more refractive index. Okay, right. For blue, the refractive index will be more. ठीक है ना?
Yeah.
That means which will bend more?
Blue.
Blue. जिसकी रिफ्रैक्टिव इंडेक्स क्या कर रहा है? बेंड कर रहा है ना.
Yeah.
जिसका ज्यादा रिफ्रैक्टिव इंडेक्स वही ज्यादा बेंड करेगा. ठीक, तो बेंड दोनों होंगी, यस और नो?
Yeah.
है ना? ये थी ओरिजिनल डायरेक्शन रे की, उसमें तो नहीं जाएगी, कोई भी नहीं जाएगी उसमें. रेड वाली थोड़ी बेंड होगी, थोड़ी इससे बेंड होगी, ब्लू वाली और ज्यादा बेंड होगी. ठीक है, ब्लू वाली और ज्यादा. अंडरस्टूड? ठीक है. एवरीवन गॉट इट? हेलो. यस. Understood?
Yeah.
Now see if this, so therefore color separation happens, right? Therefore color separation happens. This is also called, इसको लेकिन dispersion नहीं बोलते, dispersion अभी नहीं बोलेंगे. अगर if this is true, no, if this is true, then glass slab में भी होना चाहिए ना ये.
Yeah.
ये होना चाहिए ना glass slab में.
Yeah.
You should see color separation in glass slab. Yes or no?
Yeah.
If this happens, this is a phenomena, right? If this happens, so this is a glass slab में होना चाहिए ना glass slab में ये. You should see, so right, we should see color separation in glass slab also. Do you understand that the light which was this light, input light, the blue and the red were coming together, but when they're refracted in glass, blue is refracted more, so blue has a different path than the red. The moment they have different paths, you can see them separately. Okay, take one more thing. See, white light consists of 7 colors. Okay, so if these 7 colors are if this bunch of 7 colors, violet, indigo, blue, green, yellow, orange, red, these 7 are going together, what color would you see them as? White. You'll just see them as white, right? If they're going together. But if violet is going alone, then you would see this color as violet.
Violet.
Okay? So इसमें suppose all 7 colors are, मतलब basically this is white light, okay? Sunlight. So you will, इसमें 7 colors हैं, but you can't see them, right? But the moment यहाँ पे होगा, क्या होगा कि सबसे ज्यादा म्यू किसका है यहाँ पे 7 में से? रेड का लैम्डा ज्यादा है, वायलेट का म्यू ज्यादा है, तो क्या होना चाहिए? ऐसे सेपरेट होना चाहिए 7 कलर्स में. मतलब ऐसे थोड़ा सा ज्यादा एग्जैजरेटेड डायग्राम है, बट आई मीन to be precise, it is like this, okay? So विप गियोर ऐसा होना चाहिए, right? सबसे नीचे violet, and you should see colors, right? लिख लिया question, we should see colors.
Yeah.
The different colors we should see. Now why does it happen? Why does not it happen in glass slab is, glass slab क्या होता है कि यहाँ पे separation हल्का सा होता है, यहाँ पे हल्का separation होता है, ठीक है, यहाँ पे हल्का separation होता है, ठीक, ऐसे it becomes a, it's like a, थोड़ा सा हुआ, लेकिन वो separation यहाँ पे जाके फिर से combine हो जाता है, ठीक है. So therefore this separation होता है, but ये very less separation है, ठीक है. If you can further separate this, then you will see light, but different colors. But you're not able to, further separate it in a glass slab. But what happens in a prism is, तुम यहाँ पे refraction पे यहाँ पे तुमने separate किया ही है, ठीक है, लेकिन second refraction पे और separate हो जाता है. Understood? The separation thing happens first in a glass prism. The separation happens at 1, but then separation is cancelled at 2. But in prism, separation happens at 1, and then separation is further held at 2. Okay, if you can make a surface such that, अगर ये prism है ना, पर prism के अलावा कुछ और भी ऐसे, कभी कोई ऐसे surface होते हैं, ठीक है, ऐसे समझो, ऐसा कोई surface है, इसमें light ray यहाँ से आई, ठीक, फिर यहाँ पे गई और फिर यहाँ पे जा रही है. अब इसमें क्या होगा, यहाँ पे भी अलग अलग होगी, इस सरफेस पे पहले अलग अलग होगी, फिर सेकंड पे भी अलग अलग होगी, और फिर थर्ड पे भी अलग अलग होगी. तो यहाँ पे खूब सारे कलर दिखाई देंगे, मस्त एकदम, ठीक है. यही होता है किसमें, रेन ड्रॉप में. अंडरस्टूड?
So will we see more colors than what we saw in the glass prism?
You should see more separation of colors. मतलब glass prism is not the ultimate, मतलब it will not show, it is a device which shows you colors, but there are better devices which shows more colors because of simple physical property that the more refraction you have, right? And raindrops is a perfect example of that. Okay, so if you make this spherical, if you make this more, more and more, these lines are, triangle for square and then rectangle. As you go in more curved, you can make this circle, right? Understood? And then what happens? Something, one, light rays will, so you will have many colors here. Okay, understood? Okay, so you understood how dispersion happens. Okay, acha. So tell me if this is true or false. The separation of light in a prism is because the prism is made of glass. No, right? It is because of the geometry of the prism. Of course, it is made of glass. उससे होता है. अगर air का होता तो नहीं होता. Right?
Yeah.
But glass का तो slab भी है.
Yeah.
उसमें नहीं होता separation. Okay. And my next question is: if you want to see colors in a slab, what do you need to do? Suppose you want to see the colors in a glass slab, rectangular glass slab. No, you can't use the prism. You have to only use the slab.
Do we make the edges unparalleled, like somehow?
It has very good, but it has to be a rectangular glass slab. You don't have a cutter or anything.
Can we change the material?
Pardon?
Can we change the material?
Yeah, okay, change the material.
So we change the material to something which has a high refractive index.
So that is correct. Higher refractive index, higher N.
But it still retrace itself.
It will retrace itself.
What do we want?
Good, but वो बोल रहा है अगर N भी higher तो भी it will still retrace itself, no?
Sir, but like in the last one you said that it recombines because there is very less dispersion.
Yes.
So if we increase the
higher N.
yeah.
और second बहुत simple सा है इसमें, बहुत simple सी एक चीज है. What were you saying? No, you can't use anything else. Yes. So is the refraction taking place at 1? At point number 1? Yes. Is refraction taking place at point number 2? I understood. No, it is happening at both the points. Right. Yes. Refraction is happening at both the points.
How do you define refraction? Faint and medium.
Yes. I don't define. It is defined like that. Okay. अरे सिंपल है, ये टी को बढ़ा कर दो ना तुम. Okay. If it increases thickness, then its angular separation will increase over time.
Yeah.
Right. You can see now colors. So increase T. Understood?
Sir, I didn't understand the higher refractive index part.
Higher refractive index mean they bend more.
Okay.
Each will bend more. I think Prajwal, it does not work that way. I don't think I n is answer. Prajwal, see why. ये आई है, ठीक है. ठीक, सपोज व्हाइट लाइट मोटा मोटा लेते हैं, हमने 45 डिग्री लिया था. 45 डिग्री अगर लेते हैं और इसका √2 लिया था, तो एंगल 30 आ रहा था ना, ये एंगल 30. अब ये मैंने व्हाइट लाइट के लिए लिया था, मतलब सारे मोस्टली अप्रोक्सीमेट था ये, राइट. अगर इसमें इसको तोड़ दूं मैं, वाइट वायलेट और मान लो इसको दो में तोड़ूं, वायलेट और रेड, ठीक है, 2 लाइट है इसमें, ठीक. और वो वायलेट के लिए ट्रू है, तो वायलेट ऐसे जाएगा. 1 मिनट. वायलेट विल गो like this. If violet goes like this, then the corresponding red at 45 degree में red के लिए क्या ज्यादा, red bends less, right?
less.
Okay. So it will go somewhat like this. समझ में आया? Right? ठीक. Now if you increase the total overall refractive index of medium, suppose इसको √2 से कुछ और कर दिया, ठीक है, तो क्या चेंज होने वाला है? ये 30 चेंज होने वाला है. 30 मान लो 20 हो गया. सपोज इनके बीच में 1 डिग्री का डिफरेंस था, 1 डिग्री बिटवीन द वायलेट एंड द रेड. अगर तुमने ग्लास का रिफ्रैक्टिव इंडेक्स चेंज कर दिया, बढ़ा दिया, मान लो इंक्रीज कर दिया, √2 से ज्यादा कर दिया, √3 कर दिया, कुछ और कर दिया, सच दैट जो रिफ्रैक्टिव एंगल है वही 20 डिग्री हो गया, जनरल रिफ्रैक्टिव एंगल. तो वायलेट, अब जो वायलेट जाएगा वो 20 पे जाएगा, राइट. और अब जो रेड जाएगा वो 21 पे जाएगा. समझ में आ रहा है? 21 और even slightly more closer to 20. I understood.
Okay.
पहले violet और red में difference क्यों नहीं दिख रहा था? Because the angular separation between them was less. Now also angular separation between them is less.
Okay.
Understood?
Yeah.
तो नहीं देखिए, ये गलत है, फिर higher end गलत है, ठीक है. अगर angular separation को observe करना है तो let it run for some time. ठीक है. And then whatever angle between them is वो है, पर ये this will grow, this distance will grow over time. So now you can see.
Which will still require increase in speed.
Yeah. Okay. Understood? Okay. एक काम करो, अपने बुक से ग्लास प्रिज्म का डायग्राम बनाओ, उसमें कुछ कुछ जो भी लेबल्स हैं वो सारे बना दो और मुझे भेज दो. ग्लास प्रिज्म का डायग्राम बनाओ, डिस्पर्शन का डायग्राम बनाओ. तो मेक दिस फॉलोइंग डायग्राम्स. ग्लास प्रिज्म रिफ्रैक्शन, देयर इज एन एक्टिविटी बॉक्स, उसमें बना हुआ है. You have to make the diagram, you have to label all the things and send it the diagram to me, and then you have what dispersion diagram on the next page. ठीक है? Understood?
Sir, which book are you talking about?
NCRT.
Oh, okay.
With them on the side, right?